Hello friends, today we will see how to program in MASM software for finding addition of n 16-bit numbers. Addition of n 16-bit numbers. For that, how to write a program as well as how to execute the program in the DOS prompt in MASM software and get the output. So for this, the first thing, you must have a DOS box. So I have a DOS box which is already installed. You can get this DOS box in Google search. If you put Google search DOS box, you will get this. It's a free downloadable. And one more thing you need is you need a 86 file. So this should be stored in that C drive. So for this, I will be giving this 8086 folder that will be given in the uh, subscription. You could check that out. This folder will be available. So now let us start the programming part of MASM software. So once if you open this DOS box, first thing you have to mount that DOS box with the C drive, because our C drive is having this MASM software. So now after doing this, once if you get this message drive C is mounted as local directory, you make this Z drive. Already it is there in the DOS box as Z drive, so you change that to C drive. Now we got C drive. After that, if you just type edit, I'll go one by one here. So first you have to mount this using this C drive. Now I'll type that in the you could see that. So mount, and this is the uh, typing you must do. Mount C space C colon backward slash 8086. After getting the message C in the local directory, you frame that Z to C drive, so C colon. So once if you get that C colon, I'm going to type it as edit. So here I have given edit now. So I'm getting a blue window. So in this blue window alone, we will be programming whatever program, whether it is addition of two 16-bit number or two 8-bit number, or if you do subtraction. Likewise, in other videos, I will be giving for addition, subtraction, and all. Now we will be doing a program for sum of n 16-bit number. So if I say sum of n 16-bit number, so you can make the count as 5 values or 10 values. That is your wish. You can have your own values. So already I have a program here. So I will show the program now. So this is the program for uh, sum of n 16-bit number. So here these are the 5 values I'm going to use it for this sum of n 16, but you, that is your wish. You can give any values as you wish, but here it is, since it is a 16-bit addition, 16, all are 16-bit numbers here. This 1 2 3 4 is a hexadecimal 16-bit number. 5 6 7 8 is also a 16-bit number. Similarly, I'm giving some 5 values. You can, if you want, you can add 10 values, 20 values, that is your wish. So for example, I'm going with these 5 values. So that is stored in the, these are the 5 values I'm going to give. So that should be registered with a DW, saying that it is defined word. Word in the sense, in 8086 we will be considering it as a 16-bit number, so it is defined word. Then I have some more additional definitions here. Define word for 4500 is this is for the source index address. Then I mean destination index address. So similarly, we have S2 is defining 000 because the first value should be added with the accumulator which is having 0000, because the first addition should be done with 0000. Similarly, then we have to include a carry. Whenever if carry exists, you have to add this in the another register. So for that I am clearing for the carry register 0000, and here the 0005 represents how many values you are going to use it for addition of n16 bit number. So that is given by S4, which is 0005. This S4, S1, S0, S2, these are all some variables that is declaring these addresses, declaring these initialization, declaring these carry register, declaring these count registers likewise. So because in masm you cannot straight away use these values in the program. Instead of that, you must use using these variables only. Using these variables, you have to introduce that variable and make that value to come to the cx register, dx register likewise. So with this, the data part is concluded. That is, it is all related with data segment. So because these are all data that is being entered into the program. So now we come to the coding part, which is actually the programming part. Normally we could say that is the code segment. It starts from the code segment, because code segment, stack segment, data segment, extra segment, or some memory segmentation in 8086. So in that context, data are stored in data segment, and the program, the coding part is stored in the code segment. So CS is colon code and DS is data. So the program starts here. So first three lines are always common for all the programs. Whatever program if you do, whether if it is multiplication, whether if it is division, if it is block transfer or sum of n numbers, all programs we will be having always these common three lines. So these three lines are included in all the programs for whatever we are going to see in the masm software, making that this is for making the uh, arrangements with respect to extra segment and data segment. So whatever we select in the segment, so memory segmentation will be allotted based on these three instructions only. So now we will enter into the program. So first one, here I have given a instruction, say move cx comma s4, where s4 stands with 5, saying that these are the counter which allocates the number of values in the uh, addition. So in this context I have used 5 values. So cx is denoting to s4. S4 is a variable which is having 5 values. So this is the, if I check 0006, then it will be 6 values added. You have to enter in that context, you have to enter one more 16-bit number. Likewise, how many values you want to add, that many values you can include in this s4. So s4 is a variable which is used for counter in this program. In this program, s4 is used as the counter. So actually in the program context, cx is used as the counter register. Then dx is for storing the uh, carry value. Whenever if you are adding so more numbers, certainly you will be getting a carry. So that carry will be stored. Whenever if a carry exists, it will be stored in this dx register. So in that context it is used. Then ax is given with s2, saying that, so AX is loaded with S2, saying that the first value is 0000. The accumulator is cleared with 000, because in this accumulator alone, the answers will be added up and stored. Added up and stored. So in that context, the first value the accumulator must have should be fully a cleared value 0000. So that is why S2 is 0000, that is stored in this accumulator. Now we coming on to the taking this values, five values. So move si comma offset s1. So offset stands for the addresses for every data. So 1, 2, 3, 4 will be stored in separate address. 4, 5, 6, 7 will be stored in a separate address. 6, 7, 8, 9 will be stored in a separate address. So actually in a consecutive addresses it will be stored. So that is what here offset of s1. When I say offset of s1, it denotes that the address is having certain value. That value, actually the address should be stored into this si. So si comma offset, in the sense this s1 is having some address. That address is being called here. So s1 might be some address, for example 7000. In 7000 you might have 1 2 3 4. In 7002 you might have 4 5 6 7. In 7004 you might have 6 7 8 9. Why I say 7000, 7002, 7004? Because it is a 16-bit number. So 7000 and 7001 will take 1 2 3 4. 7002 and 7003 will be taking these 16-bit numbers. So just for an example, I am saying 7000, but here it is not mentioned as 7000. So automatically offset S1 will be considering whatever address you are preferring, that will be taken here in this consideration. So then coming back to the next instruction, add AX comma SI. So the first value, already as I told you, accumulator is 0000. So the first value is added. So 0000, and the pointing S1. Now it is pointing to this first value here, 1234. So that is the content of SI. SI is pointing to the address of this one. So within bracket parenthesis it is given, which means this value is taken here. So AX is 0000, and the parenthesis SI is nothing but 1234. So the content of SI is this 1234 for first source index address. So first value AX 0000, and the first value will be added. AX is 0000 and first value is 1234 will be added. So if a carry exists, that is why we have a jump if no carry. Sometimes you might have a carry, sometimes you will not have a carry. Whereas if I add 0000 and 1234, definitely you might not have a carry. So in that context, you should not increment this dx, because whenever carry exists, you must increment. Otherwise, you should skip this increment dx and come to the next line. So it is coming back to this next instruction. So in this instruction, it is showing that it is increment si. So making that uh, first si is pointing to the first address. Now I am making that si point to the next address. That is why two times I am incrementing si, since it is a 16-bit data. For example, if it is a 8-bit data, you might doing it with only one increment si. But since it is two times, it is uh, why is it two times incremented? Because it is a 16-bit number. So in always, whenever if you use 16-bit number, we must provide two times this increment si, making that 8-bit for one memory location and another 8-bit for another memory location. So totally 16-bit, in this sense two memory locations it has to switch over. So in that context, it is increment si two times. Now after getting the second value, so since one addition is over, when I do one addition here, one addition is over. Actually, we are doing sum of n 16-bit number, addition of n 16-bit number, both are correct. Sum of n 16-bit number or addition of n 16-bit number. So in that context, if you do that, so it is five additions we have to do. So if I do five additions, so here it is one addition is over. So we are making that dx, which is, I mean cx, which is pointing to number 5, is now getting decremented to 4, because one addition is over. Then if still it becomes this cx becomes 0, it should continuously add. So now it is running up jump if no 0. If cx is not becoming 0, you go back to this loop and add again this ax will have the added value. The first value which is added will be present in ax. Now the second value will be pointing now. So in this example, the second value is 4567. So 4567 will be brought in this context. So along with AX, which will be having 000 plus 1234. So 1234 will be present in the AX. So 1234 and 4567 will be added. So likewise, still it becomes CX becomes 0. That is the second addition, third addition, fourth addition, fifth addition. Once all the five additions are over, it will become 0. Now it will execute. I mean, the AX will have the answer, accumulator will have the answer, and DX will have the carry value. So that both will be stored in a register called the destination index. Destination index is pointing to 4500, which is S0 here. So in 4500, you would be storing the answer. The accumulator value will be stored in 4500, and the carry value will be stored after incrementing this destination index two times, that is 4502. You will have the carry value. Then we have some instructions here. This is to halt the program, that is print the result and come out of this program. For that we have move ah comma 4ch and interrupt 21h. Interrupt 21h is a breakpoint interrupt nearly. So in that context it will be printing the result and coming out of the program. So code ends. This is the uh, programming code which ends the program. So that is what is the fully explanation of this program. Now we will go for execution point. So execution point requires very uh, important process, so you have to follow very carefully in this context. So once once if you have completed the program, now you have to save this program. For that it is alt F. So when I press alt F, you can save as you can give and save as. And if I'm so let me give the same sum of some n 16-bit number I am giving. It is added. Now after saving this, you you have to give alt fx. Alt fx will leave out the program and come out. So now we have to execute the program in this dos prompt. So for that we have some steps. So you please note down that steps if you want, or you have to follow it properly. So for execution we have some steps in this, as I told you. So that and all is given here. So the first one is type masm file name dot asm. So in that context, so here I'm going back to this. So it is masm sum of, so what is the file name here I have given? Sum of dot asm. So masm file name dot asm. Masm file name dot asm. You will get one object file name. So if any error is there, it will clearly show here. If there is no error, it will straight away move on to object file name. Just you have to give enter, enter, enter. So if you check here, there is no error, zero warning error, zero severe error. So this is what is assembling process of this program. So now you did some kind of assembling, that is some compiling process is over in this context. So masm file name dot asm. The next is link file name dot obj. So you could see it here. So the first one is masm file name dot asm. Now the second step is link file name dot obj. So link file name is sum of, actually, dot obj here. So first one is asm. Now it is obj. So again enter, enter, enter. So you will get a warning something like that, but that doesn't makes a important thing here. Now you have to type debug and file name dot exe. So first one is dot asm, second one is dot object file obj, third one is we are going to execute this. So now if you find out here, For this, you have to give a process. So P stands for that process. So continuously you have to give process. P enter, P enter, P enter, P enter. So this will execute the program step by step. In Masm software, you have to work out the solution most probably by step by step. Then alone it will be you could find any debugging error. So in that context, you have to go for this giving P. So if you want to do it, do like this and make 5 values, not more than 5 values. If you give 10 values, then you have to give more number of process time. So you make always some 5 values, 6 values for number of values if you are giving in a counter. Now if you look at here, cxs becomes 0000. So somewhere here the program is going to end. So with this you stop. So when you get move ah comma 4c, so you stop pressing this P. Now after keeping this move ah comma 4c, you type D space ds colon the output destination address, D space ds colon 4500. So now if you look at here, this is what I'm asking you, D space ds colon the output address. So here it is D space ds colon 4500. So now you are getting some memory locations here. So the answer for this is AE12. Actually here you could see that AE12, and DX is 0001. That is the answer is 1 AE12. 1 AE12. Now let us check the answer also. So actually the program is having certain values, so that value so is actually the answer is 1 AE12. So we will, so that is the correct answer, but even though I will make you understand using the calculator so that you, so the values are, for that I want to check this, come out of this one. For that q you may come out. So now I'm typing the edit, file name is sum of .asm. So we will give these values now. Now you check here, it is 1 2 3 4 plus in hexa I'm doing 4 5 6 7 plus 6 7 8 9 plus 9 8 7 6 plus 5 6 7 8. So if you check here, it is AE12 and carry is 1. So this is what is the answer we got uh, just before. So it is 1 AE12. So even though we will try this once again, it is alt fx. So now we will check the output here. You could see it is 1 AE12 near to the 4500. So in 4500 you could see it is carry is 1. This is that 1. Then AE12, AE12 is the answer. So this is how you have to check the answer in Masm software. In the memory location 4500, you could see this AE12 and this DX value, which is 0001, which is coming as the carry 0001. It's 0001. So these four are the memory locations which will show the answer. So the steps, once again I will tell you. So first thing, you have to install the DOS box. Then this 8086 zip file will be found in this mediafire.com. So you can get this 86 zip file. Then after that you go for mounting this 8086. Then change the directory to C. Using edit, you will be getting that blue window. In that blue window you start typing the program. After saving the program, type the file name as .asm. Then using these steps, actually first one is for assembling masm file name.asm. This is for assembling. Then to create object file, it is link file name.obj. Then for execute, it is debug file name.exe. So these three are the important uh, files which is being created for execution. Then after that you have to just give p for processing till it reaches move h comma 4c. Then after getting this position move ah comma 4c, type d space ds colon output address. Then you may find your answer in the memory window. So boys and girls, so friends, with this we conclude this video. This video is based on uh, writing a program in masm, to execute a program in masm and check the output. So in checking masm software, we have to check in the memory window only. So the memory window will be available in this context, like this. So with this we will conclude this video, which is sum of n numbers, sum of n 16-bit numbers. Similarly you can do it for sum of n 8-bit numbers also. Only thing is here 8-bit in the sense, instead of dw we have to use db, defined byte. So that is also a simple program. We will be seeing that in the later videos. So now in this video it is sum of n 16-bit number. Likewise you subscribe for the video so that you could get more programs solved in masm software. Thank you.